Hi, AB Calculus students. We are working on 2009 number 6. Topic is an FTC problem. It uses the fundamental theorem of calculus. And this question is one of the three questions that's going to be on your quiz later this week. The three topics are table questions, FTC questions, and separate and integrate. And I really believe there'll be a big focus on these three on your AP exam come May 12th. All right. So let's go ahead and look at part A. First of all, before we get started, I drew the graph. I wrote the piecewise function. Now with this piecewise function, g of x they said is a semicircle. So this is just a semicircle. And then the last thing we have is they gave me an initial point. F of 0 is 5. One other small thing. They said this graph of f prime x has two x-intercepts. One at -2. And the other x-intercept is at 3 ln 5 over 3. That's really important because I didn't want to have to find what decimal that was. There's no calculator in this one. So, anyways, with that information, let's get started. So the first question asks, when would f have points of inflection? Now, if we want to know when is f going to have points of inflection, we would look at, this is part A, we would look at a sign chart of the second derivative. So let's make the sign chart of the second derivative. First thing, my graph goes from -4 to 4. And now we have to stop and think. This is f prime x. We want a sign chart of f double prime x, its derivative. So to go from f prime x to f double prime x, we need to know something about the derivative. To learn something about derivative, we look at slopes. So I'm going to look at where we have positive slopes and negative slopes and zero slopes and undefined slopes. So let's look at the slopes. When the graph here is decreasing, they're negative slopes until I hit -2. So all these slopes are negative, negative, negative. And then we have positive slopes until we hit 0.
You know that I love people.
Now it's a sharp turn at 0, but it doesn't matter. And then notice we have negative slopes everywhere else. So this is your sign chart of the second derivative. You have to label this sign chart. If you don't label the sign chart in your work, you can't give the reason we're about ready to give. So, points of inflection are where the second derivative changes signs, because this would mean that f of x was concave down, concave up, concave down. So concavity changed here and here. So we'd say point of inflection at x equals -2 and 0, and here comes our justification. Because f double prime x changed signs. But this does not work if you did not label this. If you did not label this, and you said f double prime x changed signs, you wouldn't get points for the justification. The reason is, this is just the definition of concavity. You could always say, point of inflection, f double prime x changes signs. Doesn't mean you actually understand the problem why it changes signs. So this shows you understand what's going on. Now, what if you did not make a sign chart? What could we do? Well, let's look at our points of inflection. Our points of inflection were here and here. So another justification you could say is that because f prime x went from decreasing to increasing and from increasing to decreasing. So when f prime x changes from decreasing to increasing or from increasing to decreasing, those end up being the same points that become points of inflection. So you could talk about the first derivative, increasing or decreasing. But I think it's easier to label a sign chart and just talk about the sign chart. All right, that's part A. All right. Part B, this is where all the points are. When I say all the points, 5 out of the 9 points. It's a big question. And this can be, I went back and re-looked things up, this can be on your exam. So we need to know how to do part B. Part B says find f of -4 and f of 4. So let's go ahead and start with f of -4. Okay. How am I going to find f of -4? Well, let's go way over here. If I found the area of f prime x from -4 to 0. Now, why am I specifically going from -4 to 0? You'll see in a second, but because we need to utilize this. This is my starting point. F of 0 is 5. I will be either doing two things. Either it will be initial plus net change, Or this could also be not an initial, it could be a final, and we could use final minus net change. So let's go see if it's an initial or a final. But anyways, if you take the antiderivative of this, if you follow the rules, the antiderivative of f prime x is f of x, and then following the rules, you'd plug in the top and bottom and subtract f of 0 minus f of negative 4. And notice, f of 0 is what we have, f of negative 4 is what we're looking for, and we can find this. This is simply the area. We can find the area because it's a semicircle, or a semicircle is dealt with this. Okay, so let's go ahead and compare these two. If you're on a number line, negative 4 comes before 0. So this is actually, in comparison, this one's the final, this one's the initial. So we want to know what's our initial. So our initial is our final minus the net change. All right, so our answer is the final. Our final is 5 minus, and now I need to know what is this. What is the area underneath f prime x from negative 4 to 0? Now, when we're looking for the area, we're looking for this. That is not a semicircle. That is what is left over when you start with a rectangle and you subtract out a semicircle. So, we want to know what's this area? Well, this area is a rectangle minus a semicircle. So let's start with the rectangle. The rectangle, this is 4 by 2. So you can say 4 by 2, 4 times 2. Obviously, you could also just call it 8. But it's earning. I don't have to actually simplify it. So there you go. That's the rectangle minus the semicircle. Now a semicircle is half a circle. So instead of pi r squared, it's half of pi r squared. So rectangle minus a semicircle. We just need the radius of that semicircle. And the radius of that semicircle is 2. And there you go. This is your answer. F of negative 4, if I want to find the initial, it's the final position minus, and again, this gives the net change in position. All right, when you find this area, it tells you how much f changed by. So the area underneath f prime x gives the net change in its antiderivative f of x. So final minus net change, we do not need to simplify it, that's great. That's the first part of part B. We're still on part B. The second part of part B is asking us to find f of 4. Now, by comparison, this time when you compare these two on a number line, 0 comes before 4, so this is the initial, and we need to know what this is, and this, of course, is going to be my final. So now when I want to know my final, it's my initial plus my net change. Again, the area underneath f prime x from 0 to 4 is what I need. Okay, now a couple things. First of all, we know the initial again is 5. We're given that information. And what are we going to do with this? Well, I don't know the area because it's not a simple shape like rectangles and semicircles. It's the area underneath some weird curve, but we have a big piece of information. This is the equation of that curve. So, from 0 to 4, I know what the curve is. So I'm going to erase f prime x and replace it with what f prime x is. So f prime x is 5e to the, now instead of writing it as negative x over 3, I've taught you about this a bunch, we're going to call it 1/3 x and then minus 3 dx. Okay, so we're going to take the antiderivative, plug in the top and bottom, subtract, and be done. One small thing, we actually already know the antiderivative of negative 3, which is negative 3x. And in fact, if you want to do work properly, the proper thing to do here is to basically deal with it separately. So, oops, whatever. The negative sign goes in front. But, or whatever, plus negative 3 from 0 to 4. It really doesn't matter though. The antiderivative of negative 3 is negative 3x. The only reason I technically split them up is because I'm going to use u substitution to take the antiderivative of this. When I move that to the outside, I put the right u, offset it. I want to be proper. So let's talk about what the antiderivative of this piece is. So off to the side, let's look at that. So first thing is, if I get the perfect situation, e to the u du, the antiderivative of e to the u is e to the u. So in this problem, when I have 5e to the negative 1/3 x dx, I have to ask myself, well, what's my u? Well, if it's e to the u would have to be negative 1/3 x. Therefore, my du that I would need is negative 1/3 dx. Now, I don't have a negative 1/3 dx. I have a 5. So the 5 is not what I want. I want a negative 1/3. So I move the 5 to the outside. I put a negative 1/3 offset by its reciprocal, negative 3. So now I have this negative 15 in front. And this is now perfectly e to the u du. So its antiderivative is simply e to the u. Okay. So the antiderivative of this piece right here was negative 15 e to the negative 1/3 x, and then the antiderivative of the negative 3 was negative 3. Okay. Now remember, after you take the antiderivative, you still have to plug in the top and bottom and subtract. And we are not going to be simplifying this answer. So my final answer is 5 plus, and now we're going to plug in the top and then the bottom and subtract. So I'm going to plug a 4 into both. So negative 15 e to the negative 1/3 times 4 minus 3 times 4. So I plugged in the top, and now I'm going to plug in the bottom, and of course I'm subtracting them. So now I'm going to plug in a 0. And I know I could simplify all this, but I'm not going to. So this right here is my answer for f of 4. And that's part B. It's a lot of work, but if it's a lot of work, it's a lot of points. It takes time, but you're getting something out of it. All right, let's go to part C. All right, so part C, find the value of x at which it has an absolute maximum. So we want to find the value of x when f of x has an absolute maximum. Now, this problem actually ends up being much easier than it could have been. So let me go ahead and show you really quickly things you would normally consider. Who can win the absolute maximum awards? Endpoints and critical points. So the endpoints are negative 4 and 4. Now, we actually found both of those values in part B. Now, they were ugly. We didn't simplify them, but they are there. Okay, and then critical points. Well, who can win critical points? Critical points of f. Again, we want to know, when is f at an absolute max or min? Critical points of f are when its derivative is equal to 0 or undefined. So, critical points, where is f prime x equal to 0? Negative 2 and 3 ln 5. And we're going to build a sign chart, because in this question, they don't want to know which one's the absolute max and which one's the absolute min. They say what x value will give us the absolute max, for sure. So, again, you have to label your sign chart. So this sign chart is talking about f prime x. F prime x, it's the graph of f prime x, so I say equals 0 here and here at negative 2 and 3 ln of 5/3. And then I do a sign chart. I have it's above the curve, so positive values, negative values. Okay, now look at this. We are actually done with the question. This sign chart of f prime x told me f was increasing, increasing some more, and then decreasing, increasing, increasing, decreasing. So, while these were all candidates, any one of these were candidates in the beginning for absolute max or mins. What could this guy have won? He could have won an absolute min, maybe. He could have won an absolute minimum. He couldn't have won anything. It was increasing, still increasing. This is the only one that could win the absolute max. And notice in this question, they don't ask for the y value, they only want the x value. So f has an absolute max at x equals 3 ln of 5/3. Now, how do I prove it's an absolute max? I need to prove that it was always going up and then always going down. So, f has an absolute max at x equals 3 ln of 5. Sorry about that. Alright, anyways, how do we know? Because f prime x was positive from -4 to 3 ln 5/3. We could have written this a lot more professionally, like x between negative, but whatever. And negative 3 ln of 5/3 to 4. So if we say f prime x was positive from here to here and then negative from here to here, that means that it's an absolute max. And we got our final 2 points, and there's rejoicing. All right, see you guys later.